When a power supply is first plugged in or turned on, there is a large current surge into the power supply as the input capacitors are charged. Current inrush causes the arcing noise often heard when a computer or other device is first plugged into a wall socket. Current inrush is stressful on switches, diodes, capacitors, wall sockets, etc. Many power supplies incorporate inrush limiting. The most common method is the NTC, negative temperature coefficient resistor. The NTC resistor has a high resistance of about 40 ohms when cold and a low resistance of less than 1 ohm when hot. The NTC resistor is placed in series with the input to the power supply. The cold resistance limits the input current as the input capacitors charge up. The input current heats up the NTC and the resistance drops during normal operation. If the power supply is quickly turned off and back on, the NTC resistor will be hot, so its low resistance state will not prevent an inrush current event. Another method is to use triacs or relays in parallel with a resistor. The resistor limits inrush current. A sensor circuit monitors the input capacitor voltage. When the input capacitors are charged, either a relay or a triac across the input resistor is enabled to provide a path for power flow during normal operation. Active power factor correction, PFC circuits, also minimize inrush currents by minimizing the size of the input capacitors directly connected to the power input terminals.